Hi, and welcome to a brand new video. So today we're going to be tackling the problem on the screen where basically we have a tree kind of like so, and at a specific node, it's good if the nodes before it have a value less than it. So that's a bit confusing, but if we go to the fourth node here, you can see here that the node before it is 3. So this is a good node because 3 is less than 4. Over here, 3 and 4 are less than 5, so therefore it's a good node. But for something like 1, if 4 and 3 are both greater than 1, so therefore this is not a good node. And we need to count how many good nodes are there. Now, this is actually might seem a little bit complex because we need to keep track of all the previous nodes and all that things, but there's actually a really much simpler solution. All we really need to do is keep track of the maximum value, because if this is not less than the maximum value, then it doesn't matter. It's not a good node. It's a one node or not, right? And so if we check only against the max value, then technically we're checking against everything else, right? Because if it fits the max value, it obviously it fits all the other ones. So what we're going to do is we're going to create a global variable num, and num is going to keep track of how many good nodes are there. So we're going to say this dot num is equal to 0. And then we're going to create a recursive function. So I'm going to say private void recursive is going to take in a tree node root and an int max. And then right here we have two scenarios. Either it is not greater than max or it is greater than max, right? So we don't care about if it's less than max, right? We still want to iterate through it if it's a good node or not a good node. We just don't stop if it's not a good node, right? So that's why we're just going to do a simple if statement saying if root.val greater than equal to max. So this means that it is a good node. Then we say this dot num plus plus max is equal to root.val. And then when we go outside, we just say if root.left not equal to null because we want to iterate through either way, just like I said. And then if root.right not equal to null, recursive of root.right of max. And then here you're just going to want to call recursive with root and root.val, and then just return num. So let's kind of break down what we did here. So what we did is this global variable is going to keep track of the number of good nodes, which is technically what we want to return if you see in the prompt. Given a binary tree, a good node is one where the nodes before it are less than or equal to x, right? So we need to return the number of good nodes. So inside recursive, we say that if the root.val is greater than max, that means it is a good node, then we increase the number of good nodes and set max equal to root.val, and then just iterate through the rest of the tree. So if we save this, I already created an example with this tree right over here. If we run it, you can see here that we get 4, which is the answer to this example. So hopefully this video was helpful and gave you a much simpler solution to just keeping track of all the previous notes. So hope this was helpful and see you in the next video.